We're finishing up 4.3. Still talking about where functions are increasing and decreasing and where there are relative max and min. We learned the first derivative test, and we could use the first derivative test to tell where a function has, where it's increasing and where it's decreasing, where it has relative max and min. But if we've already found the critical numbers and put them on a number line and determined the sign of the first derivative in each interval, then we really don't have to use the first derivative test to tell where the relative max and min are. We can tell that from our number line. Most of the examples that we did yesterday were algebraic, so you know what's coming today. Some transcendental. Hey, we didn't get to 36 yesterday, did we? Did we stop at 32? Okay, stopped at 32. Well, let's pick up at 36 then. We've got to talk about the good old absolute value function. Make sure everybody's totally okay with that. The directions are still find the critical numbers, find the open interval over which the function's increasing and decreasing, and then the C part says apply the first derivative test to identify the relative extrema. But if we can identify the relative extrema without using the first derivative test, we're not going to use the first derivative test. And I'll say the same thing about the second derivative test on Monday. Can you identify the critical points here? Is there anything that makes the function undefined? Are there any discontinuities in the function? No, no discontinuities. Domain is negative infinity to infinity. I could find the derivative. Actually, I'm going to have to find the derivative if I'm going to determine where the derivative is positive and negative. How do you find the derivative of the absolute value function? Could use the definition, but ugh. What do you think it's in? Yes, the definition of the absolute value function is a piecewise function. You put in something greater than or equal to 0, you get out the same thing you put in. You put in something less than 0, you get out the opposite of what you put in. That's actually the definition of the absolute value function. So the critical number here is what? -3. We're going to have one piece of the function defined for all the values greater than or equal to 3, and one part of the function defined for all the values less than 3. So let's get those two pieces here. One thing for all the values greater than or equal to 3, and then something else for all the values less than 3. If you put in any number greater than or equal to 3, you're just going to get, you can actually play like those absolute values aren't there. If you put in a 4, for example, you've got 4 plus 3 is 7. Absolute value of 7 is still 7, so it doesn't really affect the function. For any values greater than or equal to 3, this is just x plus 3 minus 1, better known as what? X plus 2. And if I'm uncertain at all, I just pick a couple of numbers. Well, let's see if I choose a 3, do I get the same thing here and here? If I choose a 3, then I have absolute value of 6. 6 minus 1 is 5. If I put a 3 here, do I get the same thing? Yeah. If I'm still not sure, I'd try something else, but I'm pretty confident about that. Sam, tell me what you're thinking.
Should be 3 or -3.
Did somebody say 3 and I just agreed with them, or did somebody say -3 and I just didn't put them right? I don't know. I don't know why I wrote down 3. I don't know if somebody suggested it and I went with it or what, but the turning point of that V shape would be at -3, because that horizontal shift always works the opposite of what we expect. So my bad. That still is going to be x plus 2, but it's not for all the x's greater than or equal to positive 3. It's for all the x's greater than or equal to negative 3. At least you caught that early enough. It was easy to fix, Sam. Thanks. All right. What about if we put in something less than or equal to negative 3? What do we get at? Let's say it was just plain old absolute value of x, and you put in a negative 7. What do you get at? A positive 7. How do you describe that relationship between what you put in and what you got at? They're opposites of each other. You put in an x, you get out the opposite of x. So you put in an x plus 3, you get out the opposite of x plus 3. Here's how I'd write it. You get out the opposite of what you put in, and then subtract 1. And I would clean that up. That would be negative x minus 3 minus 1, or negative x minus 4. And just like I did with the first half of that function, just to make sure I'm right about it, I'm going to pick something less than negative 3. Any, mini, miny, mo, negative 4. I'm going to put negative 4 here and negative 4 here and see if I get the same thing. If I put negative 4 here, negative 4 plus 3 is negative 1. Absolute value is positive 1. 1 minus 1 is 0. If I put negative 4 here, do I get the same thing? Opposite of negative 4 is positive 4. 4 minus 4 is 0. So I put what I thought, and then I like to check myself. But this is the function in its two pieces. It's x plus 2 for all the x's greater than or equal to negative 3. It's negative x minus 4 for all the x's less than negative 3. All right, so what's the derivative of the function? Well, if the function's defined in two parts, the derivative is going to have to be defined in two parts. One part of the derivative is for all the x's greater than or equal to negative 3. The other part of the derivative is for all the x's less than negative 3. What's the derivative of that function for all the x's greater than or equal to negative 3? The derivative of this piece is just 1. What's the derivative of the other piece? Did we know that without doing this? Yeah, we really did. If we were thinking really hard, that's positive 1, that's negative 1. We remember the absolute value function is just 2 rays, 2 partial lines, and the slope of this line is 1, and the slope of that line is negative 1. So we really could have found the derivative without doing this work, but I wanted to show you what that work is in case you need to do it on another problem. All right, so we've identified our critical number is negative 3. And if we look at the sign of the derivative, to the left and the right of negative 3, what's the sign of the derivative for anything less than negative 3? Well, it's always negative 1, so it's definitely negative. And for anything greater than negative 3, the derivative is always positive 1, which means it's always positive. So the parts of this problem said, find where the function is increasing. What would you say to that? Anywhere the derivative is positive, that's negative 3 to infinity. I'm not going to include the negative 3 because it doesn't really make sense to say the function is increasing at a point. It's decreasing negative infinity up to negative 3. And what about relative extrema? You see any relative extrema? Where the function went from decreasing to increasing, there must be a relative, what? Min. There's a relative min when x is -3. If you ask me what the relative min is, I would just give you a y value. But if I'm getting ready to graph and I want to be able to graph as many points as I can find, then I want to give that whole ordered pair. Where do I get the y? Into the original. Make sure you're plugging it into the original because you're graphing the original. You let x be -3 in this original function, you just get y is -1, and that's the minimum value of this function. Which makes sense because I didn't graph it perfectly correctly. What's not quite right about my graph? It is the V shape scooted 3 to the left, but it was also scooted down 1. So, fixed it. The relative min is -3, -1. I'll take it on your paper. If that's the worst thing you do on your paper, then we're all right. That's okay. There was a C part. What was the C part? Oh, the A part was find the critical number. The B part was increasing, decreasing. The C part was relative extrema. And then the D part is checking on your calculator. Don't forget that you can do that on the test. Your calculus has to back up your answer. You can't just copy answers off your calculator, but you can certainly check your answers with your calculator. All right. I have number 40 circled. I wonder what's interesting about it. It's still algebraic. Yes, my work is nice. Yeah, I don't see anything scary about that one. Why don't I let y'all just do it in pairs? Mr. Jesus, you want to be a pair? Or you're going to work on your own? Scoot down here and help Miss Emily. You're practicing being a tutor. Mr. Jesus is going to be our Cal 2 tutor next semester. How'd you like me announcing that? Miss Emily, I should have asked you to help Jesus. I was asking Jesus to help you. That was making a presumption, wasn't it? Okay, thank you. You want to check your derivative? What's making you frown?
That
X squared plus 2x minus 1.
it's using what's
Yeah. Oh, shit, I got you. Typo. I have the
yeah,
right.
yeah, you have the right
Yeah, it's the right
factor.
factor. Okay.
Thank you.
That was just confusing.
Thank you. Well, it should. It should confuse you. What do you have for critical numbers? What about -1?
It's a discontinuity.
Oh, -1 can't be a critical number if the original function's not defined there. Actually, it's good to think that at the top and write your note right here. I didn't think of it till the bottom. -1 does need to go on my number line, but my critical numbers are only -3 and +1. Is that what your number line looks like? Is that what yours looks like, Major?
I didn't put -1.
Oh, you need to, because otherwise you might say it's decreasing all the way from -3 to 1, and it's not even really defined at -3. Or excuse me, at -1. What actually is going on with this graph at -1? There's a vertical asymptote. All right, so you don't want to say it's decreasing across its vertical asymptote. You need to write those decreasing intervals. Actually, I didn't write mine down, but you need to write those decreasing intervals as -3 to -1 and -1 to +1. And then you have 2 increasing intervals. What about relative max and min? Do you have a relative max?
Yeah.
Where?
Wouldn't that be 1, 0? The 0.10.
Is that where a function, relative max has to be it was going uphill and then it started going downhill. That's actually at -3. Going uphill and then started downhill was at -3. Going downhill and starting uphill was at +1. So I got those as my relative extrema. That okay? H, is that all right? Looking at the wrong guy as I say that, but okay.
Yeah.
Let's play like you didn't notice that.
What did you say? So if there's a
I didn't say anything.
okay. So if there's a discontinuity in the original function, we put it in the number line.
Right. You have to account for that. Otherwise, you're going to say where it's increasing or decreasing where it doesn't even exist. All right. I like letting y'all do the work. You're good at it. Try a piecewise function. Actually, we were dealing with a piecewise function when we graphed the absolute value function. So we can do it. I'm sorry, what? Oh, yeah. Yeah. Did anybody happen to think to check for a discontinuity in that function? You did? I'm so impressed if you did. How would you check to see if there's a discontinuity in that function?
Plug 0 in the bucket of the equation and if they equal each other.
See if the two parts hook up. I know what a negative x cubed looks like. I know what negative x squared looks like. And independently, they're both continuous over all real numbers. So we've got this x cubed looking thing, and then it hits a parabola thing. But we need to know if those two pieces hook up. We need to know if they give you the same y values when you let x be 0 in both of them. And do they? No. I mean, 0 needs to go on your number line after you make the critical points. What do you have for critical numbers?
Just one.
Just one? Why not 0?
Because it's a discontinuity.
But is that against the definition of what it means to be a critical number? Critical number only says the function has to be defined there, but the derivative is either undefined or 0. Is the function defined at 0? Yeah, it's not continuous at 0, but it's defined at 0. So technically there are 2 critical numbers, 1 and 0. Yeah, 1 and 0 are both critical numbers. Yes, sir.
The second equation of the derivative.
Uh-huh.
In x just greater than 0.
Yes, I don't need that little or equal to. Is that what your number line looks like? Where is the function increasing? 0 to 1? Or is it decreasing? Negative infinity to 0 and 1 to infinity. Is there a relative max? Where?
1, 1.
Because that's where the function went from increasing to decreasing. That is a relative max. Is there a relative min? What about where the function went from decreasing to increasing? Yeah. The only, you can't have a relative minimum where you have a discontinuity, because the definition of relative min is it's lower than what's on both sides of it. And that's not true. Any questions? All right. Let me see if I want to, ooh. Yeah, you can do this. Oh. The only derivative of an inverse function that you have memorized, inverse trig function that you have memorized, is the derivative of arctangent x is what?
X.
1 over 1 plus x squared. And the derivative of the x is just 1, so you don't have to worry about here. Just 1 over 1 plus x squared. But you got to use the product rule. Does arctangent have any discontinuities? Boy, that was a long time ago. What is the graph of what polynomial function does the graph of tangent look like between its asymptotes? Basically looks like x cubed. So what would the inverse of that function look like? Cube root of x, it goes forever to the left, forever to the right. So no, there are no discontinuities that you need to worry about. Is there anything that makes that derivative undefined?
No.
No way to make this denominator 0 with real numbers. You could with an imaginary number. We just said there's nothing that makes arctangent undefined. So no, there's nothing that makes it undefined. What makes it 0? I would just take a wild guess and then try it. I think maybe 0. What's arctangent of 0? The angle whose tangent is 0. It is 0 because the angle whose tangent is 0 between negative pi over 2 and positive pi over 2, where arctangent always gives you an answer, that happens right here when x is 1, y is 0. So arctangent of 0 is 0, and this is 0, and 0 plus 0 is 0. So 0 is the only critical number. For the sign of the derivative, I think if x is a negative number, then this first term is definitely going to be negative, right? If x is negative, this is going to be a negative over a positive. What about this? If x is less than 0, arctangent is going to be negative. And a negative gives you a negative. So without knowing exactly what f prime of -1 is, I know it's negative. And without knowing exactly what f prime of 1 is, I know it's positive. And so there's a decreasing negative infinity to 0, increasing 0 to infinity, where it went from going downhill to going uphill. There's a minimum 0, 0. All right, how many more did I have circled? Ooh, I had 4 circled. I don't think we're going to get 4 done. So what is particularly interesting? Let's just make sure you remember the derivative for number 50. Because not everybody's getting these right on the test yet. What's the derivative of a to the ugly? The only tiny thing you left out was you just said a instead of a to the ugly. A to the same old ugly, natural log of a, derivative of the ugly. A to the same old ugly times the natural log of A times the derivative of the ugly. I forgot to ask myself in the very beginning, is there anything that makes that function undefined? No, you can let x be anything. Is there anything that makes the derivative undefined? So you can let x be anything. Is there anything that makes the derivative 0? Just 0. So the only critical number is 0. And then you could find the sign of the derivative to the left and to the right of that. What do you know about the sign of the 2 to the x squared minus 3 part? It's always positive. 2 to any power gives you a positive number. Even if it gives you a fraction, it's still a positive fraction. Natural log of 2 is always positive. So you don't even need to worry about those two factors. Anything less than 0 is going to make the derivative negative. Anything greater than 0 is going to make the derivative positive. So it's decreasing from negative infinity to 0, increasing 0 to infinity with a relative what at 0? Relative min, because it went from downhill to uphill. If you're getting a whole point so that you can graph that point, what is the value of y when x is 0? You let x be 0, then you just have 2 to the negative 3. 2 to the negative 3 is 1/8. All right, I'm looking for something. I think we have time for 2 more problems, 52, 54, 56, which look the most interesting. 52 is not that interesting. Let's do 54 and 56 to round out the week. Look at that.
That makes me want to
That's the natural log of something. Go for it.
You are 6-minded. No.
I didn't write the book.
Right.
You can do it.
This is 1 over.
The derivative of natural log of ugly is 1 over ugly times what? Derivative of the ugly. The derivative of that ugly is negative 1 over x. It's one of the few times the derivative is actually less ugly than the original function. The original function had natural log of the natural log. Derivative at least doesn't have that. Hey, I forgot to ask myself something very important in the beginning. Does that have any discontinuities or any points to watch out for? Definitely can't let x be 0 or anything less than 0, or I wouldn't even be able to do this part. And where did that come from?
If you take the natural log of it, it just gives you the x covered, so 2 minus 2, and you can take the natural log.
Let me write that down in a way I can understand it. You are absolutely right. But I know that this has to be positive because I can't take the natural log of anything 0 or negative. So I said right here, I'm going to say the domain of f of x had to be whatever kept 2 minus natural log of x positive. Because if it was 0 or negative, I couldn't take this outside natural log of it. And then add natural log of x to both sides. And raise e to both sides. Also known as change it to exponential form. X has to be less than e squared. But what else did we say? It has to be less than e squared, but also greater than 0. I'm trying to think how to write that. Magic appearing 0 makes you a note. I'm going to say because of the natural log of x in the original function. So x is only between 0 and e squared. If I want to say where the function's increasing, where it's decreasing, I'm not going to have a negative infinity and a positive infinity because this function's only defined from 0 to e squared. Now, on that interval, is there anything that makes the derivative 0? Is there anything that makes this derivative 0? Only thing that makes a fraction 0 is if the numerator is 0 and this is not. Is there anything that makes the denominator 0?
0.
0, but you said I couldn't let x be 0. And also e squared, but you said I couldn't let x be e squared. So nothing on that interval. There are no critical numbers. No critical numbers on that interval. I still need the sign of the derivative. But I've got endpoints on that interval of 0 and e squared. I can just maybe choose 1, put 1 into the derivative. If I put 1 into the derivative, would I get a positive or a negative? Which one? If I let x be 1, what's the natural log of 1? 0. 2 minus 0 is 2 times 1 is 2. So it's negative. And so what does that say about the function? Ooh, strictly monotonic. Good words. I'm going to say decreasing on the interval from 0 to e squared. And what about relative extrema? There's nowhere it changes from increasing to decreasing or vice versa, so no relative extrema. All right, last one. Just when you thought you couldn't love me anymore. This is going to help you with the SATs, Alan. Don't you smell? Have you ever taken the SAT before? PSAT, so this is your first time? You're going to rock it. Going to be all right. What's the derivative of e to the ugly? E to the same old ugly times the derivative of the ugly, which is 1 over 1 plus x squared. Is there anything that makes the original function undefined? No. We can take arctangent of anything. We can raise e to any power. So don't have to worry about endpoints or discontinuities, anything like that. Is there anything that makes the derivative undefined? No. Anything that makes it 0? No. There's nothing, e to the something that's going to give you 0, and there's nothing that makes this 0, so there are no critical numbers. No critical numbers. Means what about relative extrema? I just need to know if this function is always increasing or always decreasing. E to any power is going to be positive. 1 over 1 plus x squared is always going to be positive, and a positive times a positive is always positive. So this is increasing from where to where? Oops. Where's the homework? Here's day 2 homework. Y'all have a great weekend. Do me a favor. No matter who you love best in college football, I know who you love best in calculus. So at 7 o'clock Saturday night, Yale Roll Tide.
No,
Please! We're not playing you, so you can cheer for us.
I like LSU too.
So you're not experiencing.
They would take away my scholarship.
No, I love UT. Rocky Top was one of my favorite songs. Still is.
No, they're like, okay, you did put on a watch list. In any context.
Or if you were right.
What the heck is 50 Shades of Red coming to a college football game near you?